We can now move to page replacement. So this will be in two parts. Let's start with the first one. Let's say we end up in a situation like the following one. We have two processes. Each of them has an invalid entry in the page table, so they potentially need to load a page in a frame. The problem is that all the frames in the physical memory are taken. Okay, so we cannot, we don't have space to load a new one. So here the question could be, we can start thinking about how to deal with this kind of problems. So what do we do in such a situation? Can we replace an existing page? Can we take one, swap it out, and place the one we need? Well, you can imagine the answer to that is yes, but the question would be, should it be from process one, or it can also be from process two, if it's process one that the one that actually needs the page. Can we choose the right page to swap out? Are there pages that would be faster to swap out than others? Can it be that some page has actually very low probability to be needed in the immediate future, or even in the future or later on? So actually swapping that out, it's good, because in any case, we will not need to swap it in again. And notice that this is a different question from whether there is a page that is faster to swap out than the other. We could think, could we have prevented this situation at all, actually, so that maybe we can do something that leads us to not ending up in the same situation. Maybe it's about the pages we initially allocated to the processes. Maybe we should have given a different number of pages to the different processes. So you see, you can come up with a lot of questions about how to deal with this kind of situation. So what we're going to see now is that there are basically two things we need to discuss about all these questions. One is the frame allocation algorithm. So how many frames you give to each process when the process starts, and the page replacement algorithm. So which page to replace, which page to swap out. If you end up in a situation in which you don't have 3 frames, but you still need to load the page somewhere. And we start with page replacement. So the idea is that you want to prevent overallocation of memory. So we need to modify the page fault routine, because now it becomes more complex. It's not just a matter of find the page and put it in a frame. It might also be a matter of decide which frame should be first emptied, taking the page that it contains and putting it back to swap space or to the disk, and then load the page. As we can see, as we will see, sorry, in the future, you can play tricks to optimize here. So you could have the so-called dirty bit, so an extra bit for each entry in the page table that tells you whether the page, since it was loaded in memory, was actually modified or not. Because if you did not modify the page, then what you have there is an exact copy of what you already have in the disk. So in that case, you don't really need to swap out. You can just replace that page and then load it back later on, because it's the same page you already have in the disk. And with this step now of adding the page replacement algorithm inside the routine of the page fault, now we really separate the handling of logical and physical memory. So this sort of completes the picture for virtual memory. So the basic page replacement algorithm will look like this. So you find the location of the desired page on disk, then you try to find a free frame. If there is a free frame, okay, you use it. If there is no free frame, then you need to use a page replacement algorithm. So something that allows you to decide which should be the victim frame. So the frame that we will use to place the page you need, and before that to swap out the page it contains to disk. And in that case, you write the victim frame to the disk if it is dirty. And then, of course, you bring the desired page into the free frame, and you need to update the page table and restart with instruction and so on. So it's the usual routine for the page fault. Notice that you have potentially up to 2 page transfers, additional page transfers now with a page fault, because you might need to swap out if you don't have or if the page you want to swap out is actually dirty, so it has been modified since it was read from the disk, and then you need to, of course, load the page that you need inside the frame that you have chosen as a victim frame. Now we're going to look at different page replacement algorithms. These are the four we are going to touch. But before going into the details, okay, this is the general picture. So when you select which is the victim frame, which of course depends on the algorithm you use, you need to change to invalid the entry, and you need to swap out the victim page, you need to swap in the desired page, and then you reset the page table for the new page. But of course in the page table of the other process, not the one that you have chosen as a that contains the victim frame that you decided to free. Now, we have different page replacement algorithm because, as you can imagine, they have different trade-offs, they have different performance, they have different setups in which they can be more good or better, let's say, than others. Now, a question raises here is, how do you evaluate a page replacement algorithm? How do you see how well it performs? You cannot really compute such a score independently of the execution. I mean, it depends on how the memory looks like, how many frames you can use, and what pages you have in them, and so on. So you cannot really say how good a page replacement algorithm is out of context. So the way we do this here, and at least for this this course and how we discuss these things in this lecture, is that we usually define a reference string. So it's basically a sequence of numbers, and each number is a page that needs to be accessed. And then we count how many times, using a specific algorithm, we need to basically choose a victim frame. So how many times we result or the execution results in a page fault. And the idea is that, of course, if you are able to minimize the number of page faults, then that, of course, is a good page replacement algorithm, because you will not pay the penalty, the extra time for the page fault too many times. How many page faults you get will, of course, depend on the algorithm you use, but I guess you can agree with me that in general, the behavior of the number of page faults versus the number of frames that you have available is that when you have a lot of frames, or the more frames you have, the less frequent should be the observations of page faults should be. At the end of the day, if you have as many frames as pages you have in your process, then you know that in that case that would go to 0, because it means that you can just load the entire process, and that's basically it.